All right, 153, Chapter 3, Sample Test. And first of all, I'm going to let you know that I will give you more room on the real test to do the problems. I just wanted to save paper on the sample test. I figured you'd be working on scratch paper to work these out. Okay. First question says, for this function, determine the average rate of change. Well, first of all, this is a right side up parabola. And the average rate of change is the slope. Now, I'm not sure where minus 1 falls and 2 falls. If minus 1 happens to be on this side of the parabola and 2 somewhere here, the slope would be going down, and the slope is the average rate of change. So it would have a decreasing or average decreasing. If the minus 1 was somewhere here and 2 over here, then it would be an increasing or a positive rate of change, and same over here. So it just depends on where they fall on here. But we're not going to even worry about that. We're going to find out what f of negative 1 is, so we know how high it is at negative 1. So if I put negative 1 in here, I get 7 times negative 1 plus 3 times negative 1 squared. So that's going to be 7 times negative 1 is negative 7, and negative 1 squared is 1 times 3 is 3, so negative 7 plus 3 is negative 4. So it goes through the point negative 1, negative 4. Now let's put in the 2. So we'll have 7 times 2 plus 3 times 2 squared. And the powers go before the product, so 2 squared is 4 times 3. That part's 12. And 7 times 2 is 14. So 12 plus 14 is 26. So we have it going through the point 2, 26. Now the average rate of change is just the slope between these. So the change in y goes from negative 4 to positive 26, which is a plus 30, divided by, from negative 1 to 2 is a plus 3, so 30 divided by 3 is 10. The slope is 10. It's positive, and so on average it's an increasing function over that interval. So increasing slope, average rate of change is 10. 10 for 1. Number 2. Again, you'll have a lot more room to work. I will move to another piece of paper to work some of this. But first of all, let's see. We're supposed to find the intercepts, that would be x and y intercepts, line of symmetry, intervals of increasing and decreasing, and vertex. Well, the line of symmetry we've been doing over and over, and that's x equal negative b over 2a, which would be the opposite of 13 is negative 13 over 2 times a, which is 6. So we get negative 13 twelfths. So the line of symmetry is an equation, so you better write it as an equation. It's a line. X equal negative 13 twelfths. And that tells us also, since the vertex lies on the line of symmetry, that the x-coordinate of the vertex is negative 13 twelfths. And now to find the y-coordinate, we'll put negative 13 twelfths into the equation. So I'm going to go to a different page here, blank piece of paper, and write down we have 6x squared plus 13x minus 5, and we've got to put in negative 13 twelfths in for x. So we're going to have 6 times negative 13 over 12 squared, which means times negative 13 over 12 again, plus 13 times x, which is negative 13 over 12, minus 5. So I wrote this out this way instead of saying squared so that I can see that 6 would reduce the 12 to a 2, but not both of them, just the one of them. So I have negative 13 times negative 13, which is positive 169, over 2 times 12, which is 24. Then I have minus 13 times negative 13 is negative 169, I already did it here, negative 169 over 12, that's 13 over 1, so it just comes 12, subtract 5. Now, to make this in 24, I have to multiply numerator and denominator by 2 to get that common denominator so I can subtract these. So I have 169 minus 2 169s, which is a number minus 2 of them is just the minus of one of them, minus 169 over 24 minus 5. And 24 times 7 is 168, so this is equal to negative 7 and 1/24 minus 5, which is negative 12 and 1/24. So that's the other part of the vertex, the y-coordinate. Messy numbers there, 12 and 1/24. Okay. Now, some of you might think the increasing and decreasing is going to be difficult, but because it's 6x squared, we know it's a right side up parabola. And so it's going to be decreasing up till x is at the vertex. And then it's going to be increasing for the x's over on this side. So it's increasing from negative 13/12 in the x to as x goes to infinity. That's when it's increasing. And we don't want to include the vertex, so we put a parenthesis. Decreasing, as we go left to right, this thing is coming down, and so it's decreasing from negative infinity on the x up to negative 13/12. And not including on either one of those. So that's pretty simple. Y-intercept is pretty simple. If you put in 0 for the x, 6 times 0 squared plus 3 times 0 is 0, so we just get negative 5. 0 in for the x gets us negative 5. X-intercepts. Well, we can factor, we can use the quadratic formula. Let's factor. So we have 6x squared plus 13x minus 5. So it could be 2x and 3x would multiply to be the 6x squared. Or it could be 1x and 6x, or vice versa. Now to make minus 5, I'm going to have a 1 and a 5, or a 5 and a 1, and that would be true down here, 1 or 5 or 5 and 1, and one of those will have to be minus, so that when we multiply them we get a negative 5. So let's see here. If I use the top 5, that'd be 2x times 5, which would be 10x, and 1 times 3x is 3x, so 10x plus 3x would be 13, but one of these is supposed to be minus, so we wouldn't be adding, we'd be subtracting. And 10 minus 3, or 3 minus 10 would not be 13. So let's continue on here. So let's try the bottom ones here. 2x times 1 and 5 times 3x. 3x times 5 is 15x, and 2x, and since we're supposed to be subtracting, 15x's minus 2x's would be 13. So I need to make the 15x's positive. So I'm going to have plus 5 times the 3x and 2x times a negative 1. So if I'm trying to find x-intercepts, I'm trying to find when the y is 0. So I set each of those equal to 0. I'll set the 2x plus 5 equal to 0 and the 3x minus 1 equal to 0 and solve. So I'll subtract 5 and divide by 2 and I get x equals negative 5 over 2. If I add 1 and divide by 3, I get x equals 1/3. Now x-intercepts are points, so I don't want to leave them like that. I'm going to write x-intercept is negative 5 halves when y is 0. And the other one is 1/3 when y is 0. Now we could have used the quadratic formula. So let me write that up here. 6x squared plus 13x minus 5. So if you were having trouble factoring, you could use the quadratic formula. A is 6, B is 13, and C is negative 5. So the x-intercepts are equal to the opposite of B plus or minus the square root of b squared, which is 169. 13 times 13 is 169. Minus 4 times a times c. Well, a and c, one of those is negative, so a negative times the minus 4 is going to make this plus. And then 6 times 5 is 30, and times the 4 is 120, all over 2a, which is 2 times 6, or 12. So 169 plus 120 is 289. 289, and the square root of 289 is 17. So this part is 17. So I have negative 13 plus 17, which is 4 divided by 12, or 1/3, what we had before. And negative 13 minus 17 is minus 30 over 12, which 6 goes into both of those and makes negative 5 halves, what we had before. And we could just go to the program and see if we got, I don't know if I got it in this calculator. I don't even have it in this calculator. So you could use the program and put 6 and 13 and negative 5 in for it, and it would give you the decimal values for these, 0.33333 and negative 2.5. Okay, that's 2a. Now let's do 2b. The 2a was in general form. This is in standard form. So this one's easier for most of this, because we can look at this and see that this is a parabola that's moved to the left 2, upside down, and compressed vertically by a half, and then up 4.5. So the axis of symmetry, since it's just moved left 2, the line of symmetry is at x equal negative 2. And the vertex is at -2. And then it was compressed or whatever, and then it was taken up 4.5, so it's 4.5. The x, let's see, increasing. So if it's the line of symmetry is at -2, and this is an upside down parabola, then it's increasing as we go left to right. So from -infinity up to -2, this is increasing, again in interval notation, and it's decreasing from the -2 to infinity. For x is going this way, it decreases. So from -2 to infinity in the x, the y values are going down, 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 down. Okay. Y-intercept, you let x be 0. It's not the 4.5, which is a lot of students why I didn't want to write it, because this is because x makes both of those zeros. But x doesn't make these be 0, so we got to be careful here. To find the y-intercept, we put 0 in for the x, so we get -0.5 times 0 plus 2, which is 2 squared plus 4.5. 2 squared is 4. 4 times a -0.5 is -2 plus 4.5 is 2.5. So when we put 0 in for x, we get 2.5 for the y-intercept. X-intercepts. You could multiply it out and make it look like that and use the quadratic formula, but I recommend just solving. So if we're finding x-intercepts, so we put 0 in for the y, and we get -0.5 x plus 2 squared plus 4.5. So now we're going to solve. So we want to find x. We could square it, but that just makes it harder. Just undo things. See the x, the first thing is add 2, then square, then multiply by -0.5, and add this. If we're undoing, we do things in reverse order. Subtract 4.5 from both sides, so we get -4.5 equals -0.5 parenthesis x plus 2 quantity squared. Now we'll get rid of the multiply by the -0.5 by dividing by -0.5. So that's going to turn out to be a +9 equals x plus 2 quantity squared. Now I'll get rid of the square by taking the square root, which means I got to remember I'm taking the square root, so there are 2 square roots of 9. There's 3 and -3, and I'm going to set 3 equal to the x plus 2 that would be left if I took the square root of both sides, and -3 equal to the x plus 2. And now I will subtract 2 from both sides, and I'll get 1 is x. I'll subtract 2 from both sides, and I'll get -5 is x. So now I can write my x-intercepts as 1, 0, and the other one is -5. Oh, not there. -5, 0. Okay, this problem is going to be a lot of work, so there'll be a lot more room for you to work it on the test. Okay, I'm going to get a new sheet of paper here so we can do the next problem. And that one says f of x equals x squared minus 5x, and g of x equals -2x plus 10. And it says find the points at the intersection. they intersect when they are the same height, when f of x equals g of x. So we set these equal. X squared minus 5x equals negative 2x plus 10. Now, let's just kind of sketch this real quickly so we understand what we're doing graphically. X squared minus 5x. That's a right side up parabola. In fact, if you put in 0, you get 0. So it goes through the origin. It goes through 5 because that should be 5, 0. 5 squared is 25 minus 25. It goes through 5, 0. Since it's a right side up parabola, it does something like this going through those. I'm not too worried about the scaling here. And it also goes, the other one is a line. It goes through plus 10 with a slope of minus 2. So it's going to cross somewhere over here, and it's also going to cross somewhere over here. So that's what we're trying to find, is those 2 points. Now, we could just put this in the calculator, and I'll show you that in just a second, find those intersection points, but let's continue here. So I'm trying to solve this. I got an x squared, so I want to make it equal to 0 so I can use the quadratic equation or factor. X squared, I'll add 2x to both sides, so I'll get negative 3x. Subtract 10 is minus 10 equals 0. I could try factoring. Let's see if that works. That would be x and x. What makes minus 10? That would be 10 and 1, or 2 and 5. If I do 2 and 5, I would get 5x and 2x. They have to be opposite because this is supposed to be negative 10 when I multiply these, so one of them is negative. So if I make the negative on the 5, I get negative 5x, and plus 2x would make negative 3x. So therefore, these intersect at x equal negative 2. That's this one. And at plus 5. Oh. Because I would try to set this equal to 0, so I'd set this equal to 0 and this equal to 0, and x would equal 5. I would get those same numbers if I put 1, negative 3, and negative 10 into the quadratic formula or into my calculator, and I would get those numbers. Okay, but I didn't ask for those numbers. I asked for the points of intersection. Well, this one, let's see, if x is 5, let's make sure it is 0. If I put 5 into here, I get negative 2 times 5, which is negative 10, plus 10 is 0. So this point does look like it's 5, 0. Now, I've got to be careful here. Make sure I did this right. I'm going to put it in the other one. So 5 squared is 25 minus 5 times 5, which is be minus 25. That is 0 also. So that is correct. And it's 5, 0. Now let's do the negative 2. So negative 2 times x of negative 2, that would be plus 4 plus 10. That would be 14. So it looks like this point is negative 2, 14. Let's check by putting negative 2 into the other one. Negative 2 squared is plus 4. Negative 5 times negative 2 is plus 10. So 4 plus 10 is 14. So now I'm ready to answer this question. The points of intersection are negative 2, 14, and 5, 0. Now it says, solve for when f of x is less than or equal to g of x. Now, f of x was the parabola. G of x was the line. And it said find when f of x, the y values of the f function, for what x's are the y values of f smaller or equal to g's y values. So that's saying the height of the f curve, the parabola, when is it below the height of the line, the g curve? So f is below g or equal to g from, and we do answer this in terms of the x's, from -2 to 5, f is below the g. So it's from -2 clear up till 5, and we can be equal, so we'll include equals on there. So this is inequality notation, or we could do it in interval notation from -2 up to 5. That's when the f curve is less than the g curve. It's below the g curve. This again is talking about the y values. The height of the f curve is less than the height of the g curve or equal to it. That happens for x's from -2 to 5. Okay, so this one, the answer would be from the interval from -2 to 5. Okay, number 4. Giving you a parabola here again. That's what a lot of this section is about. And we're supposed to determine if f has a maximum or minimum. So let's answer that question. So this is 7 plus x, 6x plus x squared. So let's write it in the correct order. X squared plus 6x plus 7. And since it's a positive on the x squared, the parabola has to be opening up. So will that have a maximum or minimum? It keeps on going up, so it doesn't have a maximum, but it does have a minimum right there. So it's going to have a minimum. And find the minimum value. Well, that's at the vertex, and it says determine the vertex and the line of symmetry. Well, the line of symmetry is at x equal -b over 2a. So that's going to be the opposite of 6 over 2 times 1, which is -3. So the axis of symmetry is x equal -3. That is b. I haven't finished a yet. The vertex I would take the -3 and plug it back in, so that would be -3, put the parentheses around the negative, squared, plus 6 times -3 plus 7. -3 times -3 is 9. This would be -18. Notice it's twice as much as that, plus 7. So this becomes -9 plus 7 is -2. So the vertex is at -3, -2. And the vertex is going to be at the minimum, and so the minimum value is -2. That's the value of the minimum. It happens at x equal -3 at the vertex, but -2 is the minimum value. That's the lowest it gets. Determine where the function is increasing. Well, since it's a right side up parabola, it's going to be increasing on this side, decreasing on this side. As you go left to right, it's decreasing and then increasing. So the interval, let's start, the vertex is at x equal -3. So it's increasing for x is going bigger than -3. So we're going to say The interval where it's increasing is from -3, not including it, to infinity. Determine the intervals where the function is positive. Now that's a little different than what we've been doing. Positive means that it's greater than 0. So I'm going to write x squared plus 6x plus 7 is greater than 0. Well, that could be this part if the line goes here, or it could be the whole thing if the line is down here. And so we have to find out when it's equal to 0 to know if there's any x-intercepts. So again, we could factor if we can. Let's see if this factors. So that'd be x and x. And the only thing that multiplies to be 7 is 7 and 1. And we're supposed to be adding, well, this would be 1x and 7x. That's not going to work very well. If they were subtracting, it'd be 6, but since it's 7, and both of them have to be positive, both be negative, and so they would add, so it doesn't factor. So now we do have to do the quadratic formula. I'll do it longhand since I don't have the formula in my calculator. So x, for find the x-intercepts, is going to be the opposite of b, plus or minus the square root of b squared, so 6 squared is 36, minus 4 times a times c. Well, a is 1, c is 7, so those are both positive, so it's going to be minus 4 times 1, which is 4, times 7 is 28, all over, even the negative 6, 2a, 2 times 1 is 2. 36 minus 28 is 8. So I'm going to have square root 8 is not a pretty number. I could change that to 2 square roots of 2 if I can see that there's a 4 in it. But if you don't, you can leave it square root of 8. So negative 6 plus the square root of 8 all over 2. And I can't, if I put 2 into there, I still have to put it over here. And I can't cancel inside with an outside. So I'm going to leave it just like that. That's going to be one x-intercept. The other one is going to be negative 6 minus the square root of 8 over 2, 0. So this parabola hits at two places, minus 6 plus the square root of 8 over 2, and minus 6 minus the square root of 8 over 2, and I can figure out what those numbers are. So it hits at two places. So part of this parabola is below the x-axis and part is above. And it asks for when is the parabola positive. The y values are positive when x is greater than the negative 6 plus the square root of 8 over 2. So it's positive when we have on the interval from negative 6 plus the square root of 8 all divided by 2 out to infinity. It's also positive over here. It's above the x-axis. So it's positive for the x is negative infinity up to this place. So from negative infinity up to negative 6 minus the square root of 8 over 2. So let's put that on our answer sheet. It is positive from negative infinity up to, for all the x's, negative infinity up to this where it hits the x-axis, which was at negative 8, wasn't it? Negative 6 plus the square root of 8. Negative 6 minus the square root of 8 over 2. And for, or union, for x's out here, it's positive. It's above the x-axis. So that would be from negative 6 plus the square root of 8 over 2 to infinity. Okay, Number 5. It says solve this being greater than or equal to 0. Well, this is a parabola that's upside down. So the part of this that's greater than or equal to 0 is between the x-intercepts will be positive, and everything else will be below the x-axis. So the y values, this is going to have y values, are negative. So we need to find the x-intercepts. And if I were to try to factor this, might be a little bit tricky. So I'm just going to use the quadratic formula. The opposite of b plus or minus the square root of b squared, so that's 11 times 11, or 121, minus 4 times a times c. So a negative 4 times a negative 4 times a negative 5, there's 3 negatives, so it's going to be a negative. 4 times 4 is 16, times 5 is 80. All over 2 times negative 4 is negative 8. So the x-intercepts are, see, 121 minus 80 is 41. The x-intercepts is going to be minus 11 plus the square root of 41 over negative 8, and negative 11 minus the square root of 41 over negative 8. Which one is the bigger of those? So I'm going to work that out just to show you. So I'm going to quit here, clear. Negative 11, so the numerator, parenthesis, negative 11 plus the square root of 41, close the square root, close the numerator, divided by negative 8 is negative 0.67. Now let's do the other one. I'm going to bring that back by going second, enter, and change it to minus the square root, subtract the square root of 41, press enter, and that's 9.2. So the minus 1 divided by a negative 8 is actually the larger one. So this one is the negative 11 minus the square root of 41 over negative 8. And this one's the negative 11 plus the square root of 41 over negative 8, comma 0. And when is it larger? It's between those. So I could write either this way in this notation, and I can be equal. So negative 11 plus the square root of 41 over negative 8 is less than or equal to the numbers that we want, which are less than or equal to negative 11 minus the square root of 41 over negative 8. And do set notation. Or I can just do interval notation, which would be including from negative 11 plus the square root of 41 over negative 8 to negative 11 minus the square root of 41 over negative 8. Nope, square bracket on that side. That's the solution for 5a. Now let's do 5b. Now some people multiply this together, but wait a minute, it's already factored. If I multiplied it, I get 3x squared. That's a right side up parabola. And I want to know when it's greater than 0. Well, it's going to, if it crosses the x-axis, the parts that's greater than 0 is this part. So we'd want to say these x's is where the parabola is positive. And it's also positive over here for these x's. So I just still need to know these x-intercepts, which means set this equal to 0. And so I'd get 3x plus 4 equals 0. Subtract 4 and I get 3x equals negative 4. Divide by 3 and I get x equals negative 4/3. Notice I didn't bring down the inequality sign. That messes the students up all the time. Just find out where it's equal and then use your understanding of the graph to solve it. And we'll do that in a sec here, but now let's finish this. X minus 2. So I'm going to set x minus 2 equal to 0, add 2 to both sides, and I get x equals 2. So the 2 must be this one, 2, 0. And this x-intercept must be negative 4/3, 0. So for what x's is this bigger than 0? For the x's down here. So in interval notation, I would write from negative infinity up to negative 4/3. Since I can't be equal, I'll say open parentheses because negative 4/3 would make this equal to 0. Union from 2, x equal 2, and x is bigger, this quantity would be greater than 0, so I'm going to write from 2 to infinity. And there's the solution to that one.